Hello, I am Metin Baragüngör. I am the leader of the project group. I would like to introduce our team members once again. As you can see in the team organization, Doğukan Atakul as a hardware engineer, Sezai Emircan İnan as a software engineer, and Ayça Karataş as a system engineer. Firstly, I would like to remind the general outline of the project. Our project was to design pocket-sized smartphone control signal analyzer with a wide frequency range. In stage one, we determined the customer needs, engineering and marketing requirements, and the scope of the project. Now I want to give you some information about the general process in stage two. First, we defined the concepts and started to develop it. By taking the requirements into account, we created a general roadmap. Then we developed our level one design and created much more complicated level two design. At this stage, we combined the necessary hardware and software components to evaluate our overall system design. Now, I will briefly explain the working principle of our device through an activity diagram. This activity diagram illustrates the operational steps of the device. In the first step, the user turns on the device. In the second step, the user connects to the device via Wi-Fi. In the third step, the device detects signal from the outside. After detecting the signals, the device performs the necessary measurements in step 4. The signal processing step is in step 5. The processed data sent to smartphone in step 6. Finally, in the seventh step, the user views the processed data on the smartphone screen. Now, I would like to talk about our Gantt diagram uh, created with the information in our timeline. As you can see here, the entire process is spread over 4 months. Considering the time taken by each task, the task that challenged us in this project were the general literature review, system design, and the testing phases.
Hi, my name is Doğukan Atakul. I'm the hardware engineer of this project. This diagram shows the components and connection for the signal analyzer project. This circuit shows the signal analyzer structure. Batteries power the circuit, and the 5 volts regulator provides stable voltage. The signal goes to the ADC, which digitizes it and sends it to the Arduino Uno R4 wire. The LCD screen displays measurement results, and the op-amp circuit on the breadboard amplifies the signal. This setup makes the device portable and user-friendly for engineers and technicians. Constraints. Its small size limits components, so it might lack advanced feature and run slower. The compact design handles less data, reducing performance, and the small interface may be less user-friendly. Standards, certification, and legal issues. Ensuring a signal analyzer meets standards and legal requirements is important for safety, reliability, and market acceptance. It must follow international standards like the FCC and get the CE mark to show it meets health and safety rules. The device should also follow the ROS rule to avoid harmful substance and respect data privacy laws like CDPR to protect user data.
Hello, I'm Sezai Emircan İnan. I'm responsible for the software in our project. I will be talking about our software architecture and the risk analysis of the project. The software phase of our project is quite comprehensive and works in an integrated manner. It can be divided into 4 main sections: mobile application development, data transmission, embedded software algorithms for microprocessor control, and signal processing algorithms. If we examine the code on the flowchart, the process starts with launching the mobile application. Communication with the microcontroller is established through the Wi-Fi module. Meanwhile, the signal enters the system via the analog input module. The microcontroller sends the incoming analog signal to the ADC. The ADC converts the analog signal into digital data. The converted digital data is sent back to the microcontroller after a certain delay period. This process continues continuously to accurately analyze the signal and provide the necessary information to the user via the mobile application. So also you can see the signal processing FFT code sample in this slide. Now let's talk about the risk analysis of the project. Assessing the technical and financial risk that may arise from the development of our project's prototype to its delivery to the end user and creating alternative plans was the most important part of the project. I will briefly discuss this. The potential risks can be categorized into 3 main areas: technical, marketing, and financial risks. The encountered and potential technical risks are detailed in the report. As for the potential financial and marketing risks, there are products in the market with similar features to the one we have developed. Therefore, it is critical to produce similar quality work at a lower cost than our competitors.
Ayça Karataş. I will explain the test planning and system reliability parts. Let's start test planning with functional testing first. Functional testing provides verification that the signal analyzer is correctly performing its intended functions. The second step in test planning is performance testing. Performance testing ensures that the signal analyzer maintains its accuracy and effectiveness throughout its operating range. Environmental tests verify the performance of the signal analyzer under various environmental conditions such as humidity and temperature. Battery life testing is critical to ensure that the signal analyzer's battery life meets its design specifications. Software testing ensures that reliability of the analyzer, software, and smartphone applications. In reliability analysis, first the basic components are defined. Failure rate and reliability are calculated for each defined component. MTTF, MTBF, MTTR are calculated. Reliability for each subsystem is calculated using series and parallel formula to find overall system reliability. The reliability of each subsystem is calculated separately and the results are combined using necessary formulas.